determining density. This one's a little bit more involved. The density of an unknown specimen may be determined by hanging the specimen from a scale in air and in water and then comparing the two measurements. If the scale reading in air we're going to call FA and the scale reading in water is FW, let's develop a formula for the density of the specimen in terms of the scale reading in air, in water, and the density of the fluid. I'm going to start with the free body diagram. When we're in air, we've got mg down, and we've got FA on the scale up, and those will be balanced because it's sitting on the scale at equilibrium. When it's in water, our free body diagram is going to look similar but a little bit different. We've still got the weight down, but now we have the buoyant force up along with the force of the scale, FW. So, starting with the water, we've got FB, the buoyant force, plus the force of the scale when it's in water must be equal to its weight because it's at equilibrium. And we also know that the force of air is equal to mg. So I could rewrite this as FB plus FW equals FA. But that buoyant force is equal to rho fluid VG. So I could rewrite this then as FA minus FW with a little bit of rearranging must equal density of our fluid times the volume displaced times G. Now we've got to take another step that's maybe not quite so obvious. Let's take a look and let's say that the density of our object is equal to the mass of the object divided by the volume of the object. Therefore, the volume of our object is equal to the mass of the object over the density of the object. I'm going to use that as I rewrite this equation to say that FA minus FW equals, we've got our density of our fluid, but I'm going to replace the volume displaced with my new formula for volume, mass of the object over density of the object. So mass of the object over density of the object times G. Now it's just a little bit of algebra to prove that the density of the object is going to be equal to the density of our fluid times the mass of the object times G divided by FA minus FW. Just a little bit of rearrangement to get the density of the object all by itself. And finally, one more step, that FA, we can change that a little bit. We can rearrange things. So let's then say that the mass of the object times G, that's just its weight in air, FA. So mass of the object times G right here, I'm going to replace with FA to write that the density of our object is equal to, well, we've got FA times the density of our fluid divided by the scale reading in air minus the scale reading in water. Hopefully that gets you a good start on density and buoyancy as we start this new section on fluids. Appreciate your time and make it a great day, everyone.